Hi, my name is Jing, and today I'll be presenting my final year project titled Recurrent Neuro-Fuzzy Parallel Embedded System, which will be used to implement an automated trading strategy as well. Here are the contents that we'll be going through today. Let's start off with an introduction. This is how a neural network looks like to a user, where a trained neural network is able to produce a predicted output for the given input, but no one truly understands the logic behind the predict. While others have explored the possibility of fuzzy neural network that combines fuzzy system along with neural networks, where fuzzy system mimics human reasoning and the decision-making process by introducing the concept of linguistic variables, which is able to counterbalance the disadvantages of neural networks. The first step will be to fuzzify the input, which is done by clustering. Second step will be to train the neural network. Third will be to tag the fuzzy system with the results from the neural network. Lastly is to defuzzify it so that the input will be in linguistic terms, and this is how the process should look like. We will be going through the existing architecture that will be integrated in the new architectures later on. First up, we have the Jaeger pattern classifying fuzzy neural network that was created by Jing. It's mainly used for classification problems. Next, we have modified Jaeger fuzzy neural network, which was created by Jing as well. This architecture can be used for both classification and regression problems. Next, we'll go through the two architectures that I've created for this project. Firstly is Jaeger PC-FNN tagged with MLP, where the fuzzy system is inherited from ATI, while the learning component is replaced by MLP. Next is the main architecture of this project called Recurrent Neuro-Fuzzy Parallel Embedded System. Similar to the other architecture, it inherits the fuzzy system from modified Jaeger FNN by ATI, and it replaces the learning component with LSTM. Next, we'll go through the experiments done to estimate the ability of the architectures created. Firstly is the iris dataset, which is a categorical dataset. It aims to predict the type of iris with the measurements given. I've tested the various clustering techniques with Jaeger PC-FNN, and the accuracy is as shown. UDCT have the best recall ability, hence we'll be focusing on the results using UDCT throughout the experiments. Next, I have tested the recall ability between Jaeger PC-FNN versus Jaeger PC-FNN tagged with MLP. And we can see that Jaeger PC-FNN tagged with MLP do have the higher recall ability. Next, let's test their generalization ability. Jaeger PC tagged with MLP do have the higher average. Now let's benchmark the architecture against others. We do have the highest accuracy competing with POP-FNN with PFKP. Second dataset will be traffic dataset that was obtained from a seniors FYP courtesy of NTU School of Civil and Structural Engineering. The data was collected at exit 15 along the PIE. Firstly, I experimented the data against modified Jaeger tagged with MLP. The recall and generalization ability is indeed better than modified Jaeger. While compared to pure MLP, there's just a small decrease for both recall and generalization abilities. I've also tested the traffic dataset against RNFPS as well. The recall and generalization ability is indeed better than modified Jaeger and even modified Jaeger tagged with MLP. While compared to pure LSTM, the recall ability is quite similar to each other. However, there's a significant decrease in generalization ability for RNFPS. This is an example of rules created by RNFPS. An inference we can make by just looking at the top rules is that there might be a direct correlation between lane 1 and the output. Next, we'll be introducing the automated trading strategy, where a user can select a particular stock they are interested in, and RNFPS will predict the closing price in the future, and a genetic algorithm will be introduced to calculate the best time to sell once it detects a drop, and vice versa. The stocks selected to test the strategy includes Tesla and Apple under bull market, Bed Bath & Beyond and BlackBerry under bear market, Nasdaq and Dow Jones under index stocks, and GameStop and AMC under meme stocks. Various stocks will be tested against RNFPS to fully understand the accuracy. The following experiment period will be over 5 years, where the first 3 years will be used to train the system, while the next 2 will be tested against. The strategy used will be end-of-day trading, which utilizes closing price. Hence, RNFPS is able to predict the closing price of the selected stock, which then sells when it predicts a drop in the closing price in the near future, and vice versa. Hindsight LSTM is only able to predict the closing price of the day that is reading, while Look Forward LSTM aims to predict the closing price of the future with the current knowledge. The difference in accuracy is barely noticeable. Most of them have pretty good accuracy of about 90%. These are some examples of how the prediction looks when the look forward is equal to 5. Genetic algorithm is a search-based algorithm that offers a global and general optimization procedure. Each variation of the network structure needs a full training of the current network variation. GA is able to understand which is the best day to sell once it detects a drop in the near future, or vice versa. So here are the results. With a starting asset of 100k and no leverage, this chart shows the total asset at the end of 4 years if you select the following stocks. To conclude, fuzzy neural networks are able to predict various types of data accurately along with high interpretability, which could not have been done otherwise. RNFPS has a good accuracy throughout all the experiments. The genetic algorithm enhanced the usage of RNFPS. With the automated trading strategy applied, it is able to gain up to 63% profit even with no leverage used. Here are some of the suggestions for future work. Firstly, the system can be used to reallocate the portfolio dynamically across various stocks instead of focusing on one at a time. Next, it can be an online system instead, as the stock market is time crucial. Lastly, is to implement sentiment analysis as one of the factors. And this concludes my presentation. Thank you.